Welcome. We are going to look at how to set up two end devices using the eNSP simulator. We achieved the same target by using Packet Tracer and GNS3 in our previous videos. Now, just like the other simulators, we will be picking up two different end devices and then getting them to communicate to each other. And what we seek to achieve is one, establish a peer-to-peer network and also capture IP packets using Wireshark within the simulator. So I assume by now you already have your application set up. And then what we are going to do is choose the end devices. Now you initiate the eNSP simulator, and then from the top left corner you start the canvas. So the canvas gives you the white interface that allows for you to drop your elements or objects for use. So we pick our first item, say our client PC, which is PC1, and then we drag and drop PC2. Then we establish a connection between these two points. So we come to the connectors and then we choose the copper. Now if you don't know the type of medium, or if you don't know the type of cable that is ideal for this connection you are establishing, it is best to choose auto. But in our case, we know the specific cable, or we know the type of connection that is ideal for our work, so we choose copper, and then we click on the first item and choose the port to which we are connecting the cable. There are instances we have our computers having more than one network card, so it will depend on which card you are connecting from. So we choose Ethernet 1 to PC2 Ethernet 1. So once we have this, it means we have succeeded in what? Establishing a connection between these two end devices. Now in the previous tutorials, I drew your notice that you cannot configure a device once it's off or whilst it's off. So you need to turn on the device. We highlight all the devices by selecting them, and then we start. So you give it some few seconds and it turns your device on. So once the device is on, you can then go to the settings of the device by right clicking on the device, and then you choose settings, or you double click on the device. So once you double click on the device, you can then give it the name. So for this particular host, we say this is what our host A, and then we go to the IP address configuration. With the IP configuration, for now we do not have any device that is giving our device our object an IP address, or our PC an IP address. So we assign the IP address automatically, like we assign it statically, because we are not getting an automatic IP. So we choose static, and then we define the IP address. In our case, we use 10.11.0.1 for the first host, and then the subnet mask is going to be a class A. So we say 255.0.0.0. So once we do this, we do not need a gateway and we don't need a DNS IP, because we are not going out of our network. We are just going to establish a connection between two end devices. So we leave it like this and apply. Then we go to the next system, and then we name it host B. Once we name it host B, we come to the IP address, and this will be 10.11.0.2. It is .2 because the previous device has a host of what? .1. So if we repeat .1 here, we would experience what is called an IP address conflict, because we cannot have two devices on the same network having the same IP address. So we define the subnet mask, which is 255.0.0.0, and then we apply. Now let's see if there is actually a communication between these two end devices by generating traffic. And how do we generate traffic? We do a simple ping request, which uses the ICMP, the Internet Control Message Protocol. That is what allows for you to do a simple ping request to see if the other end responds to whatever message or request you make. So we simply say ping 10.11.0.2. It is 10.11.0.2 because that is the IP address for the other device we are trying to make a request from. So as you can see, we are getting a reply from 10.11.0.2, which is what host B on our interface. Now we can then right click on the interface and then we start data capture. So when we right click on the interface and start data capture, we expect Wireshark to initiate and then show us or let us see whatever information or traffic that is generated between these two endpoints. So we are going to again send the request. So we send the ping request whilst observing what our Wireshark does. So we say ping 10.11.0.2. So we realize that Wireshark is able to intercept the traffic that is generated between point A and point B, which is host A and host B. So we have the chart drawn here indicating that a ping request was made and then a reply was given within a specific time frame, which is say 1 millisecond or 60 milliseconds. Now this particular milliseconds is defined based on the distance between our points. So this brings us to the end of module 1. That means you should be able to establish a simple connection between two end devices, that is point A and then point B, and then you should be able to generate traffic and then analyze the data that is transmitted from point A to point B using Wireshark. I expect you in my next video where we will be able to configure the devices via giving them IP addresses from another host. Say we have a router that releases IP addresses to these particular computers on our topology, or we can set up a switch, maybe a layer 3 switch that allows for you to get IP addresses from it, so on and so forth. Thank you very much for visiting me. I expect to see you in our next class.